shortest chapter for MEC 441. We only have two subtopics. Okay, so the first one is dimensional analysis and similitude, and then the second one is for the model studies. Okay, so basically this is a very important chapter. Okay, so in a study of fluid mechanics, whereby you will be using dimensional, okay, dimensional or dimensional analysis to come out with the solution, to come out with the parameter that will be used in order to run the experiment, for example, in order to do the simulation. Okay, so basically for dimensional analysis, you are required to do the, you are required to understand the dimensional for any variable. Okay, contoh, for example, apa ni, velocity. Okay, so for example velocity. Okay, so velocity, we know that the unit is meter per second. Okay, so this is dimensional. Okay, so meter per second is the dimensional. Dia punya dimension, the dimensional ataupun dia punya unit. We call it as dimensional. Okay, so apa lagi? For example, we have acceleration. Okay, acceleration, which is du over dt. A, acceleration A ataupun G for the constant gravitational acceleration. What is the unit for acceleration?
Meter per second square.
Meter per second square. Okay, so du over dt meaning that meter per second square. Okay, so apa lagi kita ada? Pressure. This is example pressure, which is, we know that pressure equal to force over area, and then the unit is Newton per apa?
Meter square.
Meter square. Okay, so that this is the dimensional. Okay, meter per second, meter square, meter per second square, Newton per meter square. So that is the dimensional. Okay, and then similitude, we use this dimensional. Okay, and then convert in a standard similarity ataupun similitude study. Okay, so common analysis or common how to say the similarity ataupun similitude study, we use unit of mass and then length and then time. Okay, kita guna ni MLT. Mass, length, and also time. Okay, so how to apply this mass, length, and time in this dimensional and similitude study? Okay, so for example, velocity, mass over second. Okay, so in similitude and dimensional study, we can apply mass apa? M. S is apa? S time. Okay, second is time. So M over time ataupun sama dengan mt minus 1. Okay, so this is applying the dimensional to the similitude analysis. Okay, so we will be using this mt minus 1 in order to come out with the parameter. Okay, parameter, or we come out with the equation. Okay, before we proceed to the experiment ataupun apa nama ni, simulation. Okay, so contoh apa lagi? A meter per second, acceleration meter per second. Meter per second ni bukan m, bukan mass, sorry, salah ni. Ni sepatut apa? L. Oh, you apa senyap ya? Saya silap, bukan mass. M is meter. Meter is unit length. So LT minus 1. Okay, so sama kan M is meter, so the unit is similitude for length. S is T minus 2. Okay, so Newton macam mana? Newton ni sebenarnya apa? Force ni sebenarnya apa? Newton. Unit dia sebenar, unit apa? Homogeneity for Newton ni apa? Newton
MN
apa?
kg ms
kg kali dengan
m
m
s negatif
s square.
S square.
S square kali dengan 1/m square. Betul? So sebenarnya kilogram, sebab Newton sebenarnya weight, Newton sama dengan m over, this is mass kali dengan acceleration A. Betul? So mass kali dengan acceleration. Setuju?
Setuju.
Okay. So this is basic apa? Betul? So,
Betul.
M kita boleh potong. So kita convert dalam MLT punya dimensional. Kita akan dapat apa? Kilogram ni apa? Kilogram adalah mass. So kita akan dapat M S square. S square ni apa? T T tolak 2, lepas tu kita ada M. M ni apa? M mass ke M ni length which is L tolak 1. Okay, so this is how the MLT system will be used in order to come out with the equation. Okay, in order to come out with a function in order to run the experiment. Okay, so this is some overview what will be using in this analysis, in this chapter. Okay, and then the second part, which is the model studies. Okay, so model studies, it is common in order to run the experiment, we will come out with a model. Okay, model ni maknanya dia exactly the same as actual, but it is scaled down, dia dikecilkan. So kenapa dia kebanyakan model ni dikecilkan? Siapa ada idea kenapa dia dikecilkan? Kalau kereta, kapal terbang, kalau untuk model dia scale down. Kenapa? Siapa ada idea?
Jimat cost.
Okay, jimat cost lagi.
Senang nak kira.
Senang nak kira. Basically kita buat model as an engineer, we come up with model because one of the reason is to fit, okay, to fit with the experimental apparatus. Okay, so can you imagine your airplane, standard Boeing 737, Airbus 320, Airbus 330, Airbus 350, Airbus 380. So can you imagine the wing length and then the length itself for the airplane. Okay, so dia punya dimension tu, dia punya length sangat panjang. So there are no wind tunnel. Kalau kita nak test experiment, there are no wind tunnel that can fit the actual dimension for the airplane. So that's why as an engineer kita akan come up with a model. Okay, model kita kena scale down. Okay, scale down tu mungkin dalam 1/10 scale punya model 1/10, 1/60, 1/12, ikutlah. Okay, but how to come up with this model ataupun with the scale model, we must depend on the for example similarity. Okay, so for example similarity in terms of Reynolds number, okay, in terms of kalau Rayleigh number, kalau untuk yang terlibat dengan heat transfer. So kita kena come up with all this similarity. Maknanya similarity ni apa yang berlaku dekat model akan sama dengan apa yang berlaku dekat actual. Okay, so kita kena samakan the actual dengan model based on for example saya cakap ada Reynolds number. Okay, so yang tu kita akan belajar dalam chapter atau untuk second part. Boleh? So this is just only overview for this topic. Okay, So kalau ditengok kat sini, this is scale 46 1 over ni maksud dia apa ni? 1 over, maknanya dia punya scale is 1/46.6 dia punya scale model. Okay, so model L model sama dengan 1/46.6 L actual. Okay, so yang ni, and then this is apa ni? Yang ni dipanggil water tunnel. Okay, so water tunnel basically is used in order to do the experiment for the ship, for example for the submarine, untuk boat, okay, untuk design, untuk kita tengok dia punya apa nama ni, tengok dia punya flow, water flow, nak tengok dia, nak study dia punya stability, okay, kalau ada wave macam mana dia punya stability. So that, this is how engineer come up with the scale model. So basically this is scale model. The scale model is basically will be similar, exactly similar with the prototype ataupun the actual model in terms of the baseline design, okay, of an airlift bark class US Navy fleet destroyer being tested in 100-meter long towing tank at the University of Iowa. The model is 3.048 meter long. Okay, so dia punya panjang dia only 3 meter. Okay, untuk model 3.048 meter. In test like this, the Faraday number FR, Faraday number is a dimensionless. For the dimensionless number will be that is used for the channel flow. Okay, channel flow ni maknanya dalam contoh sungai, longkang, so the channel flow lah. So there is known as channel flow. So dia guna Faraday number. So maknanya Faraday number untuk FR model akan sama dengan Faraday number untuk apa nama ni, actual model. Okay, so yang ni yang saya maksudkan tadi. Ni kalau untuk apa nama ni, boat ataupun apa nama ni, military punya destroyer. Okay, so kalau kapal terbang, kalau kereta pun sama. Kita kena come up dengan actual apa nama ni, scale down model. Okay, boleh nampak tak?
Boleh.
Okay, so this is, pernah nampak kapal terbang ni? Tak pernah nampak sebab you tak pernah masuk UiTM lagi. Ke ada yang dah pernah masuk UiTM? Maksud saya masuk ke kampus, semua dah belajar UiTM. Masuk ke kampus belum lagi?
Belum.
So this is wind tunnel. Okay, so you can imagine this is wind tunnel. UiTM wind tunnel. Okay, kita panggil dia LST, low speed tunnel. Okay, and then dekat wind tunnel ni, okay, so this is wind tunnel. Air will be drawn from here. Okay, and then this is the outlet. This is inlet. And then this is the test section. Okay, so this test section, kalau kita tengok dekat sini, zoom in. This is the test section where the airplane, so this is the airplane, this airplane will be tested in this wind tunnel. Okay, so can you imagine, it is only berapa ni, saya rasa dalam 15 cm punya length. Okay, tapi dia punya actual 2.4 meter. Okay, tapi untuk testing kita hanya guna 15 cm model. Okay, so maknanya kalau in term of length ataupun dia punya chord, L model adalah berapa tu? 1, 2. 0.15, L actual 2.4 meter. Okay, so berapa scale tu? 0.15 dengan 2.4. So kita akan dapatlah dia punya scale model. Dia punya scale, length scale untuk eksperimen. Okay, so this is wind tunnel experiment dengan actual. Okay, so this is our UITM, kita namakan dia UITM blended wing body. Yang ni ada dekat mechanical you all boleh tengok. This is UITM blended wing body. Pernah dengar perkataan blended wing body?
Tak.
Tak pernah So blended wing body is a new the research basically has been done from I think 10 or 15 years ago. Okay, so this is a new. Sorry? Apa? Saya tak dengar. Hello? Bukan tanya soalan
Sorry, saya terbuka mic.
Okay. Your ATM blended wing body, basically research has been done from 2005 in UITM 2005, which is focusing on the optimization of the design optimization in terms of aerodynamics, how to come out, how to improve the lift and drag ratio. Okay, for example, basically for this aircraft, this type of aircraft consists of very high lift to drag ratio, up to 24 compared to conventional aircraft. But the main problem for this type of aircraft, basically, it is related to the stability. Okay, sangat susah untuk control the stability. Okay, so that's why this type of aircraft is not even commercialized, okay, but it is still under research at Airbus. Boeing pun ada dia punya research related to blended wing body. Okay, so blended wing body ni maksudnya dia blended lah antara wing dengan body. Dia blended, tak sama macam conventional aircraft yang kita selalu tengok. Dia tak blended antara body dengan wing. Dia dia macam just attached to the body. Yang ni pun untuk blended wing body, dia blended antara body dengan wing. Maknanya body ni pun akan boleh produce lift. So that's why lift to drag ratio untuk this type of aircraft is very high. Okay, boleh? So this is just some overview about the wind tunnel dengan model. Okay, so jap saya nak tunjuk video so you all nampak lagi dia punya macam mana kita buat eksperimen untuk actual. Bukan, maksud saya untuk kapal terbang yang actual, untuk Airbus, untuk Boeing. Boleh Ya, saya tengok. Okay. Sekejap. Window. Okay, dah nampak saya punya screen?
Nampak.
Okay. So ni saya nak tunjuk contoh. Macam mana saya nak keluar ke mana ni? Okay. Okay, saya play ya. Tengok dulu, ni contoh dekat Airbus macam mana dia punya wind tunnel section, macam mana dia scale down dia punya aircraft. Boleh nampak full screen?
Boleh.
Boleh je.
146 is an aircraft from the 1980s. It's been around a long time, and this wind tunnel model was part of the original design and certification of that aircraft. So it's not new. This aircraft is not designed to have hybrid electric systems on board. We're trying to take something that exists and turn it into a hybrid electric demonstrator. We'll switch out some of the sections of the tunnel model to put those on so that the aircraft looks like E-Fan-X. Where we're looking really at the overall design of the aircraft, so it includes aerodynamics, where we're trying to understand the forces on the aircraft.
The only changes we really found or discovered during the test program were we need slightly bigger areas, and we needed to change the porosity of some of the devices inside the ducts to ensure that they're related correctly to the full-scale E-Fan-X devices.
Okay, nampak tak dia macam mana Airbus pun untuk company besar pun dia punya wind tunnel tak adalah boleh fit the actual model, the scale down. Okay, yang you all nampak dekat screen sekarang ni, this is the data acquisition system yang betul-betul kita akan dapat daripada experiment, the wind tunnel experiment. Okay, so kalau you tengok kat sini alpha is the angle, pitching angle, the pitching angle. So saya rasa ni I believe this is the lift coefficient, okay, lift coefficient versus alpha. So kalau you tengok kat sini, lift coefficient as increase as the alpha increase, lift increase, alpha increase, and then at one point you akan tengok a sudden drop of lift. Okay, so yang ni apa maksud dia ni? You ada idea tak apa maksud dia sudden drop of lift ni?
Tak tahu.
Tak tahu Okay, tak apa. Sudden drop of lift shows that this aircraft already stall. Stall ni maksud dia apa? Stall ni maksud dia wing dah tak boleh produce lift. Kalau stall ni kapal terbang tu akan jatuh lah, tak ada lift yang tapung dia punya berat weight dia untuk kapal terbang tu. So maknanya kalau untuk this wind tunnel kita boleh tengok dia punya maksimum lebih kurang dekat 14. Maknanya 14 degree angle, pitching angle is the maximum pitching angle for this model ataupun for this aircraft. Okay, so dia tak boleh lebih daripada 14 ataupun 14 tak boleh lebih daripada 14 degree dia punya pitching angle. Kalau lebih, lift dah tak boleh produce lift. Okay, tak boleh produce lift, yang itulah akan jadi crash. Okay, dia stall and then dia akan crash lah. Tapi benda tu kalau kapal terbang memang dia dah ada warning system, and then pilot sendiri pun dah tahu dia punya maximum pitching angle. Okay, so this is example, one example for the Airbus. Okay, so kita tengok Boeing. Okay, so another aircraft which is Boeing. Tengok dia punya wind tunnel besar mana untuk Boeing. Boleh nampak
Boleh.
Okay, so this is wind tunnel for Boeing. NASA NASA. Ni actual Tengok you punya actual. You boleh bayang dia punya besar Macam mana dia punya test section tu boleh masuk orang. Bukan orang je boleh masuk kapal terbang actual pun boleh masuk. Okay, so ni semua engineer. Tu dia guna apa? Dia nak tengok apa tu? Dia nak tengok dia guna smoke in order to see the flow behavior, flow pattern around the wing. Okay, so kalau you tengok di sini dia guna half ataupun dia just apa ni? Vertical tail je rasa ni. Vertical tail je untuk dia test vertical tail untuk Boeing. Okay, bukan apa the actual model. Okay, so kita tengok satu lagi. This is Boeing 737 Max. The most controversy punya aircraft. Yang dua dah accident crash kan, Boeing 737 Max. Sekarang ni gantung.
We're conducting a wind tunnel test of the Boeing 737 MAX.
The 737 MAX is Boeing's latest design in the 737 family. It will deliver significant fuel savings over today's main competitors. And a big component of getting that efficiency is the new advanced technology.
2 tahun lepas saya rasa dia crash dekat Indonesia. Boeing 737 Max.
Moves the effective span of the wing outboard, reducing drag and improving the fuel burn.
And helping to prove the new winglet's ability to create those improvements is done here at Boeing's Transonic Wind Tunnel Testing Lab. This is where an exact scale replica of the MAX is put through a battery of tests, mimicking flight at cruising speed. From perfect dimensions.
You saw these guys check the model, and the slightest roughness in the wrong place, don't have it fixed, and make sure it's exact.
Pinpoint measurements.
If you got out of the shower and your hair wasn't dry, when you stood on a scale, we can measure your weight change as your hair dries. I mean, we're in extreme precision.
This lab makes for the most accurate results possible. And in this case, those results came back just as predicted.
In the end of our wind tunnel testing, it validated that the aerodynamic improvements, coupled with the engine improvement, will deliver at least a 13% improvement over the existing next generation.
And these results are not only validation, but another sign that the MAX is well on its way to becoming a staple in commercial aviation.
Puts us in a great position to firm up our configuration by mid-13, which will allow us to design it in 14, build it in 15, fly it in 16, and deliver it.
Okay, so boleh nampak apa yang saya mention tadi, yang kita belajar apa yang saya inform introductory part for the scale model. Okay, so for the model study untuk actual. Okay, so kat Malaysia ni wind tunnel paling besar kita ada dekat UTM, Universiti Teknologi Malaysia, Johor, Skudai. Kat situ biasanya Proton, okay, untuk kereta. And then apa lagi, UTM, Pro 2, semua dia pergi dia punya testing dekat UTM punya wind tunnel. Okay, so you boleh Google sekejap lagi, you boleh tengok UTM wind tunnel, macam mana dia punya besar dia punya test section tu, lebih kurang yang Airbus tadi dengan Boeing. And then saya rasa dekat Malaysia ni memang dia je yang ada. Industri Proton ataupun Pro 2 sendiri pun tak ada wind tunnel sendiri, memang guna yang server dengan UTM. Okay, so boleh untuk overview scale model punya analysis. Okay, boleh?
Boleh sir.
Okay, so kita proceed dengan dimension and unit. Yang ni saya dah mention tadi, dimension dengan unit yang kita akan guna mass length MLT punya sistem. Mass, length dengan length ataupun dimension, and then massa, time. Okay, so there is our this is yang saya cakap ni, force equal to MA MLT square. Okay, so this is MLT system. So kalau tengok sini, this is kalau mass, saya tunjuk ni mass, kilogram, M, length, L, time T, small t, bukan T capital, sebab T capital biasanya untuk temperature. Saya guna T besar dia. MLT, temperature, T besar, electric current I, ataupun ampere, dia punya unit ampere, amount of light CD, candela, amount of matter, mole. Okay, so biasanya kita akan guna tiga ni mass, length dengan time untuk kita punya dimensional analysis. Okay, for example, what are the unit and dimension of each of these term? Okay, so kita dah buat velocity ni. Apa velocity ni? Velocity apa ni?
Meter per second.
Meter per second. So meter per second, length
LT minus 1
Negative 1.
acceleration, meter per
second square.
So
LT minus 2
LT minus 2. Absolute viscosity ataupun dynamic viscosity apa? Ingat tak? Mu. Tengok balik mu apa? This is density, rho, pressure. Mu apa unit dia? Kilogram per hour? Meter
per second.
Second. Betul? Kilogram meter second, betul. So kilogram apa? Kilogram mass.
M
L tolak 1,
T tolak 1
T minus 1. Rho, unit dia apa ya? Rho?
VG
kg per apa?
Meter
cube.
Meter cube. So dimension dia M
L tolak
L cube.
3
power of 3. Pressure, force over pressure Newton per
Meter square.
meter square. So kat sini MLT dia apa?
L minus
MLT
2
minus
T
minus 2.
minus 2. Okay, so this is how to convert from the unit to the dimension MLT system. MLT system. Boleh So kita akan guna this system lah untuk similitude punya analysis. Ada yang tak faham? Boleh
Boleh.
Boleh.
Okay, so dimensional homogeneity. So basically dah explain untuk chapter 1. Dimensional homogeneity basically it is common untuk equation. Dia kena sama lah, homogeneity ni sama. Kiri sama dengan kanan. Okay, kalau tak sama dia tak boleh, dia tak akan jadi equation. Okay, so contoh Bernoulli equation. Okay, so Bernoulli equation kita ada 3 terms. Okay, standard kan. Kita ada pressure, contoh apa ni? P, kalau P tambah rho V squared over 2 plus rho GZ sama dengan constant. Betul? So unit dia ni apa? Pressure. So semua akan jadi pressure. Semua maknanya akan jadi Newton per meter square. Yang ni pun akan jadi, kalau you masukkan dia akan dapat Newton per meter square. Yang ni pun rho GZ, of course hydrostatic force, hydrostatic pressure Newton per meter square. So maknanya this is dimensional homogeneity. Ataupun Bernoulli equation dalam satu bentuk, dalam satu ni lagi adalah P over rho G plus V squared over 2G plus Z equal to constant. Kalau ni dalam bentuk apa? Untuk Bernoulli equation. Kalau belajar chapter sebelum ni. Ni dalam bentuk apa? P over rho G V squared over 2G plus Z. Head kan? Betul? Tak ingat dah? So unit dia apa ni? Kalau head unit dia apa? Semua meter. So maknanya homogeneous lah. Semua length. Okay, faham Masuk dimensional homogeneity. Boleh?
Boleh.
Boleh.
Oh ni dah ada. So saya tak perlu explain lah. Semua dah ada ni. So kalau P over rho V squared over 2 G Z ni dalam bentuk energy. Okay. So P pressure. So unit dia semua energy. Yang ni unit dia semua pressure, Newton per meter square. P over yang ni unit dia semua meter. So semua adalah homogeneous. Okay. Non-dimensionalization of equation. Okay. So non-dimensional is very useful in order to compare between experiment and simulation, ataupun to compare antara our simulation with others simulation. Maknanya simulation ataupun eksperimen yang kita buat, kita nak compare graph, kita kena compare apple to apple baru boleh compare. Okay. So biasanya kalau kita nak compare apple to apple, kita kena compare in term of non-dimensional punya analysis. Okay. So non-dimensional ni maknanya apa? Maksud dia apa? Tak ada unit lah. Non-dimensional ni no unit. Okay. Non-dimensional ataupun kita panggil dia dimensionless. Okay. So contoh kalau tadi contoh apa untuk video tadi Airbus dia buat eksperimen, dia guna dia punya dia punya model ataupun dia punya wind tunnel besar, so dia boleh letak model besar. Okay. Kita nak buat eksperimen dekat UiTM, dekat mechanical, kita punya wind tunnel kecil je. Okay. Wind tunnel kita kecil, berapa meter je. Berapa sentimeter dia punya kita punya maximum model. Okay. So kalau kita nak compare antara result UiTM wind tunnel dengan result Airbus punya wind tunnel, kita tak boleh compare as it is. Kita kena compare in term of dimensionless punya analysis. Okay, barulah kita compare apple to apple. Kalau tak, dia takkan jadi apple to apple sebab yang kat sana lain. Okay, dia punya flow pun lain, dia punya velocity pun lain. Tapi yang dekat UiTM, sebab kita punya wind tunnel kecil, model pun kecil, velocity pun kita akan reduce ataupun velocity pun tak sama dengan velocity dekat Airbus. Okay, so kita kena come up dengan dimensionless. Dimensionless ni contohnya apa? Contoh kalau velocity, kalau kita nak compare in terms of velocity profile, okay, velocity profile, kita compare with velocity U over U, apa nama ni? U reference. Okay, ni sebenarnya, ni apa? Inilah sebenarnya kita punya U over U ada dimension ke tak?
Tak.
Tak ada sebab dia bagi benda sama kan. So this is dimensionless. Dimensionless. Okay, so maknanya kalau kita nak tengok velocity profile, contoh kapal terbang tadi, okay, kita tengok velocity profile dia dekat sini. Okay, dekat transition, contoh transition. Kita nak tengok velocity profile dekat sini. So kita pun plot velocity profile, kita dapatlah macam ni. Dia punya velocity profile. Okay. So this profile must be U over U U reference. Okay. Kalau kita nak compare dengan apa yang kita buat dekat wind tunnel kita. Okay. So dia ni maksud dia dimensionless ataupun non-dimensionalization of equation. Okay, tu contoh. So if we divide each term in the equation by the collection of variable and constant whose product has the same dimension, the equation is rendered non-dimensional. Ini contoh non-dimensional. Contoh kalau length kalau length, contoh ni eksperimen dekat Airbus. Dia punya C adalah 8 meter contoh, 8 meter panjang, 4 meter tadi lebih kurang 4 meter contoh. Tapi dekat UiTM kita punya length hanyalah 15 ataupun 0.15 meter. Okay, so kita kena come out with dimensionless. Barulah kita dapat dia punya actual ataupun kita boleh compare benda sama apple to apple. So maknanya kita kena dimensionlesskan C yang kita wind tunnel dekat UiTM ni 0.15 bahagi dengan 4 meter. Okay, so meter dia akan jadi dimensionless. So semua ni you akan bahagikan dengan 4 meter. Okay, so nanti you dah saya tak tahu dalam apa nama ni MEC 445 554 ataupun 454. MEC 454 you ada belajar ke tak untuk lab, untuk scale model. Kalau ada you akan buat benda-benda macam ni lah. Okay, clear? So normalize the equation. If the non-dimensional term in the equation are of order unity, the equation is called normalized. Okay, so normalized maknanya equation tu kita samakan dengan satu semua. Okay, so of order of unity. Okay, so each term in a dimensional equation is dimensionless. Okay, so non-dimensional parameter in the process of non-dimensionalizing an equation of motion, non-dimensional parameter often appear, most of which are named of notable science or engineers, for example, Reynolds number and Faraday number. Okay. Nanti dalam MEC 442 untuk fluid mechanics tu, you akan come out dengan equation of motion ataupun Navier-Stokes equation. Okay. So Navier-Stokes equation ni kita boleh come out with non-dimensional ataupun dimensionless punya equation. Okay. So dalam equation of motion tu akan ada terms Reynolds number. Okay. So 1 over Reynolds number. So maknanya equation tu adalah dimensionless punya equation. Okay. So yang akan belajar MSc 442. Ni contoh. Kalau P bahagi dengan P bahagi dengan P reference, semua bagi dengan P reference, yang ni kita akan dapat all the terms are now non-dimensional ataupun dimensionless. Okay. So from the Miller equation is found by dividing each additive term by pressure. We use P infinity ataupun pressure reference. Each resulting term is dimensionless, which is 1. Okay, so sebab the unit unit sama kan, so kita akan dapat satu lah dia punya unit ataupun dimensionless unity. Okay, boleh untuk dimensionless ataupun non-dimensionalization of equation. Boleh
Boleh.
Okay, so dimensional analysis and similarity. Only few real flow can be solved exactly by analytical model. Okay, analytical. What is analytical? Analytical ni maknanya kita boleh solve based on equation. Okay, so normally analytical method only useful when it is one dimensional punya analysis. Okay, so contoh dia apa? Analytical contoh one dimensional flow dalam pipe, so kita boleh solve guna analytical. Okay, one dimensional, and then it is kita boleh solve based on real flow. Okay, and then kalau kapal terbang ataupun jet ataupun boat tadi, kita tak boleh guna analytical, kita kena guna numerical. Sebab apa? Dia punya flow memang complicated, and then there are various phenomena around that wing. Okay, and then it is not one dimensional. In fact, near to the wing ataupun near to the wall ataupun near to the body, the flow is always three dimensional. Okay, three dimensional, ada rotational, ada viscous. So we need to use numerical instead of analytical methods. Okay, so experimental measurement is needed to check the analytical result. Kita nak compare. So kita kena guna experimental punya measurement. Experimental work in laboratory is time consuming and also expensive. Okay, so to come up with wind tunnel yang kecil macam dekat UiTM pun, the price is too expensive. Apalagi kalau kita nak buat besar macam dekat UTM. Okay, UTM tu saya rasa involve with million. Saya tak ingat berapa dia punya cost, tapi million of money in order to construct, to build that size of wind tunnel. Okay, and then time consuming, time will be spent in terms of model, construction of model, in terms of preparation, okay, to check the force balance, and then to check the computer punya system. So it is time consuming. So a method is required to obtain most information from viewers' experiment. Okay, so dimensionless parameter can be used to correlate data using minimum number of plot and minimum duration. So the solution is based on dimensional analysis yang kita belajar tadi, yang kita guna tadi. So and then experimental testing in full size prototype is either impossible or too expensive. Yang ni saya dah explain tadi. It is impossible to test the full scale of airplane dalam wind tunnel. Okay, so that's why kita come up with scale model. Testing can only be conducted through model in the laboratory. and then there must be physical similarity. Physical similarity ni maknanya sebiji lah, apple to apple, ataupun dia punya model sama dengan dia punya prototype ataupun the actual model. Tu maknanya physical similarity. And then the solution adalah similarity based on scale model. Okay. So similitude is the study of predicting prototype condition from model observation. Yang ni untuk second part untuk this chapter. Okay, so illustration. This is just to illustrate if we want to run the experiment. Okay, in order to investigate drag force on sphere. Okay, you ada bola, and then you want to calculate the drag force FD. You want to do the experiment in order to investigate the drag force on a sphere. Okay. So parameter influencing the drag force on the sphere is of course dia punya shape lah, dia punya physical, which is diameter of sphere ataupun ball to itself, and then fluid velocity, fluid passing through the ball punya velocity, and then fluid density berubah. Kalau air lain, kalau water lain, dia punya parameter. Viscosity antara air dengan water lain, surface roughness. Okay, surface roughness which directly related to the viscous ataupun the surface tension antara fluid dengan sphere. Okay, so let's limit the parameter with the quantities that are both controllable and measurable in the laboratory. For example, diameter kita boleh control, velocity kita boleh control, rho kita boleh control sebab kita boleh control rho, kita boleh guna water, kita boleh guna air. So in that we can control rho and also of course the viscosity. Okay, so the drag force on a sphere depend on this parameter. So we write in terms of function. Force is dependent variable. Benda yang kita nak cari, drag force is known as dependent variable. And then independent variable D, dia punya diameter, velocity, rho and mu. Okay, so we can read F is a function of D. F is a function of D, diameter, velocity, rho dengan mu. Okay, so kalau kita nak plot ataupun kita nak buat eksperimen based on diameter lain, velocity lain, rho lain, mu lain, macam mana kita punya masa ataupun plot yang kita kena ataupun graph yang kita kena plot kalau kita nak depending on all these variable. Okay, 4 variable ni. Okay, so kita kena curve of F versus velocity, curve of sebab kita guna 4 independent variable ni kan, velocity, diameter, rho dengan mu. So dependent variable F versus V, F versus D, F versus rho, F versus mu. Kalau kita nak F versus V, maknanya yang 3 lagi tu kita constant, fix. D, rho dengan mu kita fix. Kalau satu eksperimen, satu curve ni kita ambil 10 bacaan, 10 values of V and then 10 value of D, 10 values of rho, 10 values of mu. So number of the experiment to be conducted 10 power of 4. Sebab apa? 10 reading 4 parameter V, D, rho dengan mu. Okay. So duration of the experiment suppose 10 minutes per reading. Kalau contoh kita nak dapat bacaan yang stable 10 minit satu reading. So kita akan dapat 100,000 minit, 10.04 100,000 minit bersamaan dengan this hour, bersamaan dengan 208.33 days, bersamaan dengan 10 bulan ataupun 20 working days per month. Okay, so 10 bulan masa yang perlu kita ambil untuk come out with this data and then graph. Kalau kita buat eksperimen satu-satu based on yang ni ada 4 variable je, independent variable, velocity, diameter, rho and mu. Kalau you imagine kalau ada banyak lagi dia punya independent variable yang kita kena consider. Okay, dia punya, kalau you nak masukkan surface roughness, so masuk lagi surface roughness. Okay, so you boleh bayang berapa dia punya masa yang kita kena spend untuk plot all this graph. But this can be reduced based on dimensional analysis. Okay, so for example, by dimensional analysis, F rho V squared over D squared ataupun F equal to rho VD over mu. Rho VD over mu ni apa? Tak baca 1, 2, 3. Oh, tak baca lagi. Rho, dah chapter 2 ataupun chapter 1. Rho VD over mu adalah Reynolds number. Okay, so based on dimensional analysis, we only need to plot one curve, which is y versus x, maknanya ni versus Reynolds number of experiment 10 reading, duration only 100 minutes. So instead of 10 bulan tadi, based on dimensional analysis, kita hanya perlukan 1 jam 40 minit punya eksperimen. Okay, dimensional analysis rho VD over mu, which is Reynolds number, and then kita variedkan dia punya independent variable. Okay, so where y equal to f over rho v squared over d squared ataupun x equal to rho vd over mu. Okay, so kita boleh dapat dia punya plot hanya less than 2 hours instead of maksudnya tadi kalau kita nak buat satu-satu, rho ni satu lain, v ni lain, d lain, mu lain tadi tapi sebenarnya rho vd over mu ni adalah based on dimensional analysis. Okay, so we can come out based on dimensional analysis only one variable. Rho vd mu ni jadi satu variable which is known as Reynolds number. Okay, so macam mana nak come out with this analysis? Kita ada dia punya method yang kita namakan repeating variable ataupun nama dia method of repeating variable ataupun nama dia Buckingham Pi theorem. Okay, so tapi ini kita akan explain sekejap lagi. Kita rehatlah dulu 15 minit. 11.30 kita start balik. Boleh?
Boleh, sir.
Okay.
Boleh, sir.
Okay, sambung sikit. Boleh? Semua ada?
Boleh.
Okay, so untuk dimensional study, dimensional analysis, kita boleh guna function dependent and independent variable in order to plot the graph. Okay, so we can reduce the number of experiment based on dimensional study ataupun dimensional analysis. Okay, so for this slide, notion, ni notion untuk example, if z equal to ax square plus bx divided by cy cube power of 3 plus d, z is known as independent variable, while x and y is dependent, independent variable. Balik saya kata. Z is a dependent variable, x dengan y adalah independent variable. Okay, so we can say that z is a function of x and y. Okay, so x and y ni adalah independent variable. Okay, so we can define in terms of function dependent variable x, independent variable of x, y and z adalah dependent variable. Okay, so yang ni kalau kita nak macam mana kita nak recall ataupun kita nak buat notation based on function, z is function of x and y ataupun sama je dengan function of x, y and z equal to 0. Okay, so untuk contoh ni Bernoulli equation kita define in terms of E, which is energy, untuk pressure dengan head in terms of length ataupun meter, P over rho V square over 2 plus GZ. So kita boleh E adalah dependent ke independent variable? E dependent. So independent ni apa? Ni P rho V G dengan Z, which is independent variable. Okay, so kita boleh buat dalam bentuk function. E, energy is a function of P rho V G and Z ataupun sama dengan function F E P rho V G Z equal to 0. Okay, so sama dengan P total dengan H. H adalah head. So head is dependent variable. P rho V G Z adalah independent variable. Okay, so we can use this notation is important in order to identify the dependent and independent variable for the dimensional analysis. Okay, so untuk this analysis, untuk Buckingham Pi theorem ataupun repeating variable ni, kita akan sambung esok sekali dengan tutorial. Okay, so maknanya esok kita akan masuk Buckingham Pi theorem dengan repeating variable and a few example how to solve for the dimensional analysis. Boleh?
Boleh.
Okay, so ada soalan tak? Belum Okay, so esok kita akan masuk macam mana kita nak cari dimensional macam mana kita nak come up with the dimensional analysis. Okay, so macam mana nak stop recording?